Good morning and welcome to our final live lesson for COP26. It's great to have you with us, and if you've joined us already this week, hello again. And if this is the first time you're logging in, hello to you as well. We're really looking forward to sharing our lesson with you this morning. The first thing I'd like to do is just remind you that you can ask your questions. Please get them coming in because we've got two great panelists later on in the Q&A, both called Ed Brown and Ed Towers, a farmer and an agronomist. So please do get them in. You can see up on the screen, there's two different ways that you can interact with us, and we're really looking forward to having your questions. Right, let's get started. So COP26, as you probably know, is a United Nations climate change conference that aims to unite the world in tackling climate change. In this lesson, we're going to look at the carbon cycle and how the human population is changing the planet. We'll see how farmers are working hard to tackle climate change and other environmental issues, and what we as ordinary people can do. So we'll start off by looking at what the atmosphere is and what the gases are within it. The Earth's atmosphere is mainly nitrogen, about 78%, with about 20% oxygen. It's been roughly these proportions for millions of years. The remaining 1% of the atmosphere is made up of other gases such as argon, water vapour and carbon dioxide. The amount of carbon dioxide is tiny, only 0.04%, but that tiny amount can have a dramatic impact on the Earth's climate. So how does that carbon dioxide get into the atmosphere in the first place? Carbon dioxide enters the atmosphere naturally from living organisms. For example, both animals and plants produce carbon dioxide by a process called respiration. Respiration is the process by which energy is released from food using oxygen from the air. The air we breathe out contains only about 4% carbon dioxide. All plants and animals respire 24/7, and so therefore release carbon 24/7. Plants also take in carbon dioxide during the day by a process called photosynthesis. Photosynthesis is the process by which plants make food such as sugars and starch using carbon dioxide from the air and water from the soil using energy from sunlight. Photosynthesis only happens during the day and only when plants have enough warmth and water. So carbon dioxide has been cycled between the atmosphere and living things since green plants first appeared on Earth about 3.5 billion years ago. This is a biological carbon cycle, and carbon dioxide is cycled quite quickly, over a period of a few hundred or thousand years. There is a similar carbon cycle between the atmosphere and the living things in the ocean. Carbon dioxide from the atmosphere dissolves in seawater naturally. The top layer of the ocean is full of microscopic plants called phytoplankton. They photosynthesize during the day, taking carbon dioxide from the ocean and releasing oxygen into the water. Phytoplankton keeps the oceans oxygenated for animals such as fish to stay alive. In a similar way to land plants and animals, carbon dioxide is returned to the atmosphere by animals and plants respiring. Oceanic life also respires 24/7, releasing carbon dioxide back into the air 24/7. There's another biological carbon cycle that takes place over also for a few hundred or thousand years. There's also a geological carbon cycle which takes place much more slowly. It takes place over millions of years rather than hundreds of thousands of years. Some geological processes, such as volcanic eruptions, can release huge volumes of carbon dioxide. Heat from magma deep underground breaks down rocks such as limestone, releasing carbon dioxide into the magma. We've already seen that carbon dioxide from the atmosphere dissolves in the oceans. Some of that carbon dioxide can react with other chemicals in the seawater and sink to form new deposits of limestone, but the process takes millions and millions of years. Living organisms that die and sink to the bottom of the ocean in sediments may form oil or gas, but once again, this process takes millions and millions of years. The new limestone deposits may eventually come into contact with magma and be broken back down again into carbon dioxide, and so the cycle starts again. So we've seen that carbon dioxide levels in the atmosphere have remained roughly the same for millions of years. However, there is some change, as this graph shows. The graph shows how carbon dioxide levels have changed over the last 800,000 years. You can see that the amount of carbon dioxide has varied between about 0.02% and about 0.03%. The amount varies naturally and in cycles. Scientists have been able to measure these carbon dioxide from ice cores in Antarctica. The cyclical change of carbon dioxide level matches with the Ice Age cycle. During an ice age, carbon dioxide levels in the atmosphere are low. In the warmer periods between ice ages, the interglacial periods, carbon dioxides are higher, and you can see from the graph at the right-hand side that we can just coming out of an ice age. So carbon dioxide is stored in different places around the Earth. This image shows it stored as carbon dioxide in the atmosphere, as carbon compounds in all living things. In soil as dead organic matter called humus, as limestone, and as fossil fuels such as oil and gas. Carbon dioxide is also stored as carbon dioxide dissolved in the ocean and within sediments at the bottom of the ocean. However, over the last 200 years or so, man has greatly changed the surface of the Earth. The human population has risen from less than 1 billion people to over 7 billion. Many of these people live in central heated or air-conditioned buildings, use cars, buses, trains and planes for transport. All these need an energy source to make them work. Much of our energy needs have come from fossil fuels over the last 200 years, and we've used coal, oil and gas in power stations to generate electricity and as fuels for vehicles. Burning fossil fuels releases carbon dioxide into the atmosphere faster than it can be removed by natural processes. Construction of roads and buildings needs a lot of cement and concrete. Making cement from limestone in a furnace releases carbon dioxide into the atmosphere, and additional carbon dioxide is released from the fuel that's needed for the furnaces. This is all happening at a time when forests such as the Amazon rainforest are being destroyed for agriculture. The trees in these forests store massive amounts of carbon dioxide as they grow. They remove more from the atmosphere, The result is that we're releasing much more carbon dioxide into the atmosphere than ever before. Over the last 50 years or so, we've started to realize that what that carbon dioxide is doing to the Earth's climate. You can see from the graph that carbon dioxide has risen to much higher levels over the last 200 years than during any other time in the last 800,000 years. So what effect is this extra carbon dioxide having? The biggest effect is on our climate. Weather patterns that have been fairly predictable for centuries have started changing. Some places on Earth have become drier with drought, causing famine, and agricultural land is becoming desert. Higher temperatures and drought have also led to forest fires in countries such as Australia, France, and the United States. Forest fires destroy trees and other vegetation, releasing carbon dioxide into the atmosphere. We're also having a greater number of extreme weather events. You can see here the effect of Hurricane Katrina. When that hit the southern United States in 2005, it caused flooding and destruction in an area over the size of Britain. Closer to home, there's been many extreme weather events such as heat waves, storms and floods in the UK, which have proved challenging for many people, especially farmers, as you saw in the live lesson on Tuesday. Greenhouse gases, or gases that cause global warming and climate change, well, there's three of those. The three main greenhouse gases are carbon dioxide, nitrous oxide, and methane. Once these gases are in the atmosphere, it can take a long time for them to be removed by natural processes. The time needed to remove half the gas from the atmosphere is called its half-life. You can see from the bar chart that carbon dioxide and nitrous oxide have got a long half-life compared with methane. You can see from this graph that the amount of methane in the atmosphere actually reduces quite quickly. For every 100 kilograms of methane released into the atmosphere, 90 kilograms will be removed after 40 years. Natural gas is mainly methane, and gas leaks at gas rigs and from pipelines release methane into the atmosphere. Methane is also produced by the digestive systems of cattle and sheep, and from natural decay of animal manure. Compared with methane, carbon dioxide lasts much longer in the atmosphere. You can see from this graph that after 40 years, 80% of the carbon dioxide released today will still be in the atmosphere. So even if we stop burning fossil fuels tomorrow, it will still take decades for carbon dioxide levels to return to their natural level. Nitrous oxide is another greenhouse gas which is long-lived. Nitrous oxide produced naturally by bacteria in the soil, but we're adding to it by using artificial fertilizers and from sewage treatment. The UK government has been taking a strong lead to reduce carbon emissions over the last few years. For example, there's renewable energy incentive schemes such as domestic solar panels, ground source heating, and for wind turbines. There have been incentives for landowners to plant new forests. From 2030, all cars and vans must be electric or hybrid. Conventional power stations that burn fossil fuels will be phased out in favour of carbon-neutral power stations. Petrol for cars already has 10% bioethanol, and that proportion will increase over time. Diesel fuel is currently 7% biodiesel, and that too will increase over time. Farmers are on the forefront of reducing greenhouse gas emissions. For example, to reduce the need for artificial fertilisers, they are leaving fields fallow, so not growing crops for a year, to allow the soil to recover. Fallow fields are often planted with clover, a crop that is great for helping soil to become much healthier. Traditional practices such as crop rotation are also being used alongside cover crops and fallow fields. Ploughing the land turns over the soil and it allows bacteria and oxygen to break down dead organic matter called humus. That releases carbon dioxide and other greenhouse gases. The soil is a great carbon sink, and it can be preserved by no-till or minimum till farming techniques. For example, using a harrow to break the top surface of the soil for planting preserves the humus deeper down. Replacing artificial fertilisers with organic manure also improves the organic matter in soil. A lot of these new practices being used come under the term regenerative agriculture. Jenny went to meet agronomist Ed Brown, who you can ask questions to later, to find out more. Over to Jenny.
I'm here in Shropshire with Ed, who is an agronomist. Agronomists are the people who advise farmers on how to maintain their productivity whilst maximising their soil health. Ed's really passionate about something called regenerative agriculture, and one of the main methods involved in that is something called no-till. So Ed, thanks so much for being here with us today. Can you explain to us a bit more about no-till and the processes involved?
So regenerative agriculture is a method of agriculture which focuses on maintaining a level of productivity but relying an awful lot less on manufactured inputs such as fertilisers and pesticides. And the way in which it achieves that is placing a real focus on soil health.
Okay.
And there are a number of key sort of principles involved in regenerative agriculture, one of which is no-till, crop establishment, and the other is cover crops.
So cover crops, can you tell us a bit more about that?
So cover crops are seed mixes which we plant in the field between our cash crops. So for instance, if you were going from a crop of winter wheat into a crop of spring barley, you would plant a cover crop over the winter, which you would then take out before you plant that spring barley. And the reason that we use cover crops, we use lots of different species, and they all have different root architectures which help to build natural structure within that soil. They also help to fix nutrients or stop nutrients from leaching over the winter. They build organic matter for us and generally just give us a real boost in terms of soil health before that following spring barley crop or any other spring crop that we might want to plant.
So when you say organic matter, what are you talking about with that?
Okay, so those cover crops whilst they're in the ground, those ones behind us that are nice and green and growing now, they'll be taking the sun's energy.
Yeah.
They'll be converting that in the plant through the process of photosynthesis, and what they then do is pump out through their roots carbon-rich root exudates, which feed soil biology, and that biology then in return feeds that plant with nutrients. So by a simple process of taking sunlight and converting it through photosynthesis, they are pumping carbon down into the soil.
Okay, and so the no-till method, what's involved in that?
So what we mean by no-till is basically you're establishing a crop without any tillage. That's quite simple. Traditionally, to plant this crop of oilseed rape, for instance, we would perhaps plough or use some quite intensive form of cultivation to be able to create a seed bed and then come and plant our crop. But this field has been established using no-till, so we've used the machine behind us, which is a seed drill, just to come straight into the stubble of the previous crop and drill that seed straight in. So we've not disturbed the soil at all.
So traditional methods do disturb the soil quite a lot,
yeah.
And the implication of that would be, what would that be for carbon?
So with the sort of higher intensity soil disturbance methods of crop establishment, you're introducing a lot of air into the soil.
Okay.
Once that air is introduced in the soil, it basically wakes up lots of bacteria within the soil, and they look for something to feed on, and what they feed on is the organic matter within the soil. So by moving lots of soil and introducing lots of air to establish our crops, you're basically gassing off organic matter.
Right.
And that's what we want to try and avoid.
And that's basically releasing carbon back into the atmosphere.
Correct.
And so the no-till method, because it's minimal disruption to the soil, releases less carbon.
Correct.
So are there any other advantages of the no-till method?
So as well as keeping carbon locked in the soil,
yeah.
No-till is also much more efficient because it saves money on diesel and also saves on labour.
Oh, okay. And any disadvantages?
Disadvantages might be that to buy a piece of machinery like that is much more expensive than some of the more traditional pieces of kit. But once you've made that initial investment, the savings are there year on year due to reduced cost of crop establishment each year.
Okay, brilliant. Well, thanks so much for talking to us. Let's go back to Josh in the studio.
Really interesting stuff, and you'll be able to hear a bit more from Ed later in the Q&A section. So what else are farmers doing? Well, to improve biodiversity, they're restoring hedgerows to encourage birds and to provide natural windbreaks for livestock. Field margins also improve biodiversity by allowing wildflowers to grow, which helps to sustain pollinators such as bees and other insects. Another great carbon sink are peatlands, such as those found in the upland areas of the UK. Many have been destroyed to provide peat for agriculture and gardening, but many farmers and other landowners are working hard to restore peatlands and ensure that they are used sustainably. They are also working hard to restore traditional woodland areas. To reduce methane emissions, many farms use animal waste to make biomethane. Biomethane can be stored in large tanks and used as a fuel to generate electricity. Livestock also produces a lot of methane by belching and breaking wind. And changing and improving their diet can reduce emissions by over 30%. One such farmer who's using this technique is Ed Towers in Lancashire. Jenny went to meet him and find out more about that. Over to Jenny.
So as Josh was saying, there's loads of really exciting cutting edge work happening at the moment in farming in order to reduce climate change. And one really, really interesting example of this is Braid's farm here in Lancaster. I'm here with Ed, the dairy farmer, and he's really passionate about reducing the methane emissions of his cows. So Ed, can you just tell us, how have you done that, and tell us your story?
Yeah, absolutely. So we've done that through feeding a garlic and citrus extract. Scientists, a research company in Wales, found that certain components of garlic could reduce the methanogenic bacteria in a cow's rumen.
Okay.
So a cow will eat grass. That will then go into one of its 4 stomachs and it'll regurgitate it and swallow it down.
Right.
It's actually the microbes in the cow's stomach that digest the grass, not the cow.
Okay.
And then the cow digests the microbes.
Right.
Then microbes come in 2 types. So there's the methanogenic bacteria and the non-methanogenic bacteria.
Okay.
And what they found is that the garlic will only knock out the methanogenic bacteria. So you can then feed that product, which is less than 1% of the cow's diet.
Okay.
And then you feed all of the normal food and grass that a cow would normally eat.
Yeah. Yeah.
And the cow will produce less than 30% less methane than she used to do, which it's so early on in working on reducing methane is a really big percentage.
No, that's a
cut down on.
huge percentage. Yeah. So how did you come across this? How did you find out about this supplement?
So my brother was doing a research into actually a seaweed, whether that could reduce the methane emissions.
Right.
And whilst he was researching that, he came across this company called Mutral that had this garlic and citrus product that was ready to feed to cows.
Yeah.
And they were looking for a farm where we could basically feed it to our cows, and because we sold our milk to coffee shops, we could then demonstrate that either customers were happy to pay more for that, or they were going to buy more off you because of that. And so we were kind of trying to prove the commercial case that dairies might want to feed this. And so we provided the cows to do the science. They provided the feed. And then we contracted Scottish Rural University College to come down and do the measurements on the cows and actually to do the science to say this is what you've reduced. Methane's invisible and it's odourless, and so it's not something that you know how much your cows are releasing. You don't actually see it. It's something that you need specialist gear, and they actually came and used a laser.
Wow.
Pointed the laser at the cow's nose, and they pointed it there for 4 or 5 minutes. And they were basically waiting for the cow to burp and then measuring the volume of methane between the nose and the laser. Every time the cow burped. So they did treatment groups and not treatment groups, and treatment periods and non-treatment periods. And looked at the difference between each group of cows.
So they kept everything else the same, and then they just fed the supplement to one group and not to the other, and then measured and compared the difference.
So we had treatment periods and non-treatment periods, and saw what the difference. And you
saw the effect of the supplement. That really is amazing. And what were the other effects that you found when you tested out the supplement?
So we actually found that the flies didn't bother the cows anywhere like as much through the summer, and so that was a really unexpected benefit. And flies biting cows through the summer is a real pain. It can give them infections, it can make them agitated and uncomfortable. And so that was a great benefit. The one effect that we were looking out for that we really didn't want to have was garlic flavoured milk.
Of course,
So the scientists actually, they fed cows up to 10 times the dose rate that we were feeding, and then they could start to taste the taint. But at the level that we were feeding the cows, there's no taint in the milk, so that was a real relief to us.
Wow, that really is amazing. And you are the first farm in the world to have tried out the supplement, aren't you?
Yeah, so beyond that, we're the first farm in the world to feed this product, measure a reduction, and then we're actually selling carbon credits. So because the feed obviously costs something to feed the cows,
yeah,
we can reduce that, and then companies can buy that benefit of reduction, and then that can then incentivise farmers that maybe wouldn't be selling to coffee shops or down their own niche brand to be able to afford to feed the product to reduce their methane emissions too.
Yeah.
So that ability to sell carbon credit is really good in terms of an incentive for farmers.
Yeah. And so what was your incentive? What made you start to look at this from a personal perspective?
Well, from a personal perspective, I'm 30 today, and
happy birthday.
Thank you very much. In my lifetime, I'll probably see whether we achieve staying under 2 or 1.5 degrees in global temperatures, and so I don't want to, run a business, produce milk and make money or not, and actually be part of the problem. If we can, I want to be part of the solution.
Of course, yeah.
And so that really gives much greater purpose to what we're doing here at Braids Farm, and makes it worth getting out of bed every day if you're doing something that's actually making the planet a better place, rather than in the media you hear a lot of negative stories about dairy and how it's actually bad for the planet. Well, if we can be the first step or kind of lead the way for demonstrating how actually we can stop this kind of Achilles heel of cattle, which is methane production.
And that's just such an amazing, interesting example of how farmers are fighting against climate change. Thank you so much for that. We'll go back to hear more from Josh in the studio.
Fantastic, and then really interesting and great results that they're getting up at Braids Dairy there. So one of the questions we've had come in that I'm going to answer now by a bit of this presentation is people have asked what they can do in terms of reducing emissions themselves. So there's quite a few things you can do. There's more than you think. For example, every time you go shopping, you can make wise choices. So for example, by buying British produce, we reduce the amount of fuel used by ships, lorries and aircraft that bring food to the UK. An added bonus is that our food production standards are the highest in the world, so you know you're getting great quality food when you buy British. If you look out for the red tractor mark on food packets, that's a really good way to identify where your food has come from. It's not just about food and eating though, we do need to think about the 6 R's, so refuse, repair, reuse, reduce, replace, recycle. So the first thing we should be doing is refuse to buy goods that have wasteful packaging or that have been transported over great distances, often needlessly. Rather than throwing things away that aren't working properly, we should consider repairing them, or if we can't, by finding someone who can repair them. We should look for ways to reuse things. Reusing plastic containers for food in the fridge or freezer is far better for the environment than plastic bags. We should reduce the amount of fuel we use by having our home a little cooler and avoiding unnecessary trips in the car. That might mean using a bus, walking or cycling instead. We can replace our domestic appliances with more energy efficient ones, but only when they really need replacing. And finally, if we do need to throw something away after it's used, we should look at ways to recycle it efficiently. Well, the great news is that I've got both Ed Towers and Ed Brown now to answer some of your questions. So I'm just going to whiz over to our question screen over here. And good morning, Ed and Ed.
Good morning.
Morning.
Fantastic. So we've had some great questions in. I'm just going to head off first. We've got the first question. I'm going to bring some stats in because we've double checked this with our climate change team here. Because the most upvoted question we've got is how much carbon does the meat industry produce end to end? From Mr. Jenkins' year 10 class. Really good question. It's quite hard to quantify, so what I want to do is give you some UK stats. So in the UK, 10% of carbon emissions, including methane, nitrous oxide and carbon dioxide, come from the agricultural industry. And of that, 4% of UK emissions are from livestock production, and that includes dairy as well as meat. What it doesn't include, though, because you've asked end to end, is the transport. So in the UK, 27% of emissions come from transport. Right, so that's enough of me answering questions. I'd love to ask some questions now to both the Eds. Let's get cracking. So, question for you, Ed Brown. what crops are best at reducing emissions that we've had in here?
Wow, good question. I guess any crop can be good at reducing emissions, provided it's produced in a sustainable, low emission way. So you can take any crop really that's produced in the UK and find better ways to produce it. So whether that be using less fossil fuels from diesel to actually plant and then harvest that crop, whether it be from using less synthetic fertilizers like nitrogen, phosphate, potash, or whether it just be by reducing food miles. So you know, putting local food in local supermarkets and consumers then choosing to buy local as well. So you can pretty much reduce the emissions of any crop. Some will be worse than others because inherently there are more processes involved with harvesting that crop. There might be more passes with a tractor, more fertilizer needed, but you can improve all crops really.
Brilliant.
Hope that answers the question.
Ed. I'm going to flip a question to you, Ed Towers up in Lancashire. I've been asked, I'm going to say, the question is, can we meet the demand for beef in the UK, just with UK producers? But I'm going to say beef and dairy, obviously, is a little bit more relevant to you. Can we meet that demand just from UK producers?
Yeah, I think we can. It's a case of demand is actually slowly decreasing at the minute, and the biggest kind of elephant in the room around food and can we meet the demand is if we stop wasting so much, we can definitely make the biggest contribution to doing that, and that's part of that. Reduce, reuse, recycle messaging is actually a huge proportion of food waste is wasted. The figure used to be around 30%, but I think in the last 10 or so years, we have reduced the volume of food waste, but it's still a horrendous figure of around 20% of food that's produced not making it into consumption. So that's the biggest thing that we can do, is actually just to utilize everything that we buy and not waste it.
Yeah, absolutely. Thanks, Ed. And it's been a theme that's come up constantly this week, that actually the highest level of emissions coming from the food chain are within food waste. And it's great to think about ways we can reduce that. Question for both of you. Are there any other further ways that you're reducing carbon emissions, or in your case, Ed Brown, advising farmers to reduce carbon emissions? We'll go to Ed Brown first, then Ed Towers.
Okay, so I think probably the two key areas would be working towards ways of reducing nitrogen fertilizer. Nitrogen fertilizer is a real big one. It's really inefficient as a product. Most of the nitrogen that we apply to our crops doesn't actually end up in the crop. It's an incredibly energy intensive process to create nitrogen fertilizers. So that one is a real standout point for me. And something I'm working on farms at the moment is finding ways to reduce nitrogen fertilizer, and we're getting there. You know, by having diverse rotations, building up natural fertility in soils and organic matter, we can definitely reduce how much nitrogen we're applying. And I guess the second one is reduction in tillage and therefore diesel usage. So looking at ways to plant and establish crops using much less disturbance, much less tillage, therefore reducing diesel usage, but also by moving less soil, you're not burning through organic matter that's already in that soil and therefore releasing more carbon. So I guess they'd be the two that I'd pick out.
And Ed Towers?
Yeah, in terms of the livestock sector, the main thing that farms can do is just called resource use efficiency. So it's about being the most efficient farmer you possibly can, not having animals that are sick and non-productive or even, heaven forbid, dying, and actually having really healthy stock on healthy soils and healthy land is the number one thing you can do. It's if you can increase your output without increasing their inputs that Ed Brown's talked about, such as fertilizer and diesel, that's kind of the first step you can do, is just be very, very good at just farming in general. So that involves kind of down to the smallest detail of looking after your baby animals and making sure they've got enough colostrum, which is the first milk from their mothers, right up to, reducing antibiotic usage from having clean environment for the cows to be in. So it's really about being a good farmer overall is the first biggest thing that you can do. There's other areas that you can look at, or we are looking at, and that's when you start to talk about renewables or solar panels, or I know JCB are now producing electric tractors and working on a hydrogen range. And there are other things and innovations that are coming along that will really help to help farmers reduce their carbon footprints, because at the end of the day, we can't stop doing what we're doing and just produce no food. We just need to be able to produce food in the least destructive way possible. The work to use renewables or have electric tractors and that sort of stuff, it's really about industry coming along. So an individual farmer can't come up with a tractor that runs on solar power or something like that. It's really about big companies like JCB coming up with these solutions, or the government coming up with solutions to get hydrogen as a usable fuel rather than diesel. And so some of that is a bit farmers waiting for the technology to come available, and then the other part is farmers actually spending a bit more extra money on that rather than the cheap old fossil fuel guzzling tractor, actually spending more money on a vehicle that might be able to run off electric or hydrogen, and showing JCB that actually, yeah, there is a demand for that, and that's another way that we can influence industry to provide the tools that we need to do our jobs that don't burn fossil fuels.
Fantastic, that's great. Two really good responses, and it's great to have both your insight. And kind of moving on to that insight for both of you, there's kind of world leaders from all over the globe currently in Glasgow, and the UK government are up there representing us. What would both of you ask, if you could ask the UK government anything in terms of helping UK agriculture, what would you ask them to do for farmers at this climate summit and beyond that? We'll go with you first, Ed Brown. Gosh,
that's a difficult one. If I just pulled out, so we've already got plans in place for the phasing out of farm subsidies in the UK, and for that system to be replaced with ELM's Environmental Land Management Scheme. And I actually would commend the people who put that together so far, because it's really ambitious. It's putting lots of the steps in place that need to happen to build a more sustainable agriculture in this country. But what I would really say to them now is actually, please implement it, make sure that it is implemented, provide the research, the funding, the necessary resources for farmers, not just within the UK, but Europe and across the world, to be able to adapt more of these sustainable principles. And we'll get to where we need to get to. I think the knowledge is there. The people are there to have come up with these kind of schemes in the first place. They might need some refining, but it's already there. But what actually needs to happen now is just some doing rather than just talking. Brilliant. That's a great response. And Ed Towers?
My foreword would be, don't export the problem. So what I don't want to see the government do is to kind of put all these green sanctions on UK farmers and then import food from countries around the world that have got no kind of green credentials, or the government have no control over what they do. So there's potentially a scenario going to be created where farmers in the UK have got very, very strict standards, which is good, which I'm pleased that kind of the base layer is being brought up. Not everybody can come up with the sort of innovations and engage with the sort of things that we've done. But if they're going to set that bar really high, don't then import food from countries around the world that then don't have any standards and can undercut UK farmers' prices, because it's going to make our businesses non-sustainable. And if we're going bust but doing all the green stuff, that's a really, really bad example for the rest of the world on how to farm. And so, yeah, please don't export the problem.
Brilliant. Listen, thank you so much to both of you. Your insight has been so valuable with this project, and it's great to see the work you're doing, building a sustainable future for the students that are watching this broadcast right now going forward. So thank you so much to both of you for joining us. We really appreciate your input. We're coming to the end of the lesson now. Just a point as well, I mean, it's a really good kind of segue on to what Ed was just talking about UK standards and production. There's an activity that you can actually do as part of this lesson post now, as you've finished, all about British beef supply and comparing it with the rest of the world. So I do implore you, take some time to do the PMI activity that we've created with the Association for Science Education and just have a look at some of the different outcomes and the differences between UK food production and the rest of the world. And equally, please do carry on looking out. Like we said, what can you do as a consumer is the best thing? Buy local, buy sustainable British food. Thank you so much for joining us this week. Even if you've joined today or for the rest of the week, we really appreciate you coming and finding out more about British agriculture. A huge thanks to our panellists today, but again, all through the week, and the team behind the scenes as well, who've worked exceptionally hard. I hope you really enjoy the rest of the COP26 period. There's so many fantastic resources out there from different providers. So do keep having discussions, keep having debate, and you as young people, I implore you, keep driving this agenda because you're doing a great job and we love to see your passion. Thank you very much, everybody, and that's us signing out for COP26. Bye-bye.